Alrighty, so we had just started talking about quadratic equations. We looked at the factoring method, and basically when you are trying to use the factoring method, we also saw that we needed to use the zero factor property to be able to, get our solutions for the equation. So I wanted to continue our discussion with the second method, which is the square root property. Now, basically for the square root property, the idea is that our equation should be in a format that looks like this. So you should have your x squared on one side and a constant term on the other side, but you can modify that. So it just does not have to be x squared on one side and a number on the other side. If you look at examples 4 and 5, you can actually also have an expression which has an x in it. So you can have 5x plus 2, and that whole thing is squared. And then you've got a number on the right-hand side. Or if you look at number 5, we have x minus 3, the whole quantity squared on the left-hand side, and then we have a number on the right-hand side. So the general format is we should have a square term, with our variable in it on the left-hand side and a constant term on the right-hand side. Now, based on this value of k, we can actually decide, what type of solutions our quadratic equation will have. So the idea is if that k value is going to be positive, then we will actually end up getting two real solutions, which means our answers will be real numbers. If that k value happens to be negative, kind of like what we have here in number 5, so if k value happens to be negative, then we will actually end up getting two imaginary solutions. So they will have that imaginary number I as part of it. And if k is equal to 0, then actually you will only end up getting one solution. So depending on the value of k, you can kind of see what our three different types of solutions might end up looking like. So let's pick an example over here from our homework. Okay, so let's see. So number 4 was kind of the example we had done last time with factoring. So let's pick an example here with our square root property. So maybe something like this. You can see we are given n to the second power minus 23. So the first thing we want to do is to be able to solve this with our square root property. We actually need to take that 23 and move it over to the right hand side. So the first thing we are going to do is add that 23 on both sides of our equation so that we can end up getting n squared equals 23. So the way this square root property actually works is because we have n raised to the second power. So of course, if you want to get rid of the second power, you have to use a square root. So that's what we end up doing over here. We have our equation, and then we're actually going to take a square root on both sides of our equation. And anytime you take a square root, you actually end up getting one positive and one negative root. So this will actually be positive and negative square root of 23. Now, of course, over here, the square and square root on the left-hand side will end up canceling each other out. So you will cancel out the square root and the square on the left-hand side, which will, of course, just leave us with n on the left-hand side, and then you will have plus or minus square root of 23. Now, I did want to talk about why we have to use that plus or minus sign. So just think about, the number 4. I can take 2 times 2, and my product will still be 4. Or I can multiply negative 2 with negative 2, and my product still comes out to be positive 4. So you can see technically when we take 4, or if you think about it as a square root of 4, you can get an answer of positive 2 or negative 2. So that's the reason why with square roots, we always put a positive or a negative sign in front of it, because you can have 2 roots which would give you the same result. So that's the same thing happening over here. Now we have n equals positive or negative square root of 23. Now, can we simplify that 23 down? Because if you had like square root of 25, we would get 5 as an answer. Or even if you had a number where you could bring something out, which would be a perfect square, Can we do that with 23? What would be the factors of 23? Or is 23 a prime number? Because 23 does not go into 3. You can kind of try that. Of course, it's not an even number, so it does not go into 2. 23 does not go into 7, doesn't go into 11, doesn't go into 13. So you can try a couple different combinations, but you will actually see that 23 is in fact a prime number. So we are not able to simplify this anymore. So you can have positive or negative 23 as your answer. So if you want, you can write it as negative square root of 23 and positive square root of 23 as your solution set. I believe actually my math lab will let us actually type the answer in this format also. So let's take a look at that. I need to make this a little bit smaller. So if you click on that answer box, you will see your little menu option pops up on the bottom. So you will notice they are actually giving you this plus or minus sign over here. So you should be able to use that when you're typing your answer into the answer box. So we'll start with our plus or minus symbol, and then we can do square root of 23, and then we'll check our answer, and there you go. You can see that works out really well. Okay, so let's clear this. So that's just a simple example to show you how the square root property works. Now, just like I was telling you, you can have different versions of the same problem. So here we are given z plus 5, the whole quantity squared, equals negative 81. So we're going to try and apply the same idea here. So of course, we want to start by taking our equation. And then just like we did before, we will take a square root on both sides. Now keep in mind, you will have a positive and a negative on that square root of negative 81. Of course, on the left-hand side, the square root and the square cancel out, leaving us with, of course, just the value on the inside, which will be z plus 5. Okay, there we go. And then can you tell me how we can simplify that square root of negative 81?
Would it be 9?
Just 9?
Would be 9i.
Yeah. Because, anytime you have a negative on the inside of your radical, it becomes an imaginary number. Because, again, if you remember, we define I as being square root of negative 1. So the simple thing here you have to do is just separate that negative from the 81. So you can write it as negative 1 multiplied into 81. And then when we separate these, you can have square root of negative 1 and square root of 81. So this guy here will become I. And then, of course, now you can just do square root of 81, which would be 9. So that gives us 9i. All right, very nice, guys. So we end up with 9i over here. And then, of course, remember, you should still have the positive and the negative sign there. Let's make that bigger. And then, all you have to do now is just get rid of that 5, move it to the right-hand side, and you end up with z equals negative 5 plus or minus 9i. So again, if you wanted to write these as separate answers, you can write this as negative 5 minus 9i and negative 5 plus 9i. Okay, and that's it. Another thing I wanted to point out in terms of these I or imaginary number I, if you take a product of I multiplied into itself, or basically I squared, you are essentially, okay, that should be I times I. So what that actually means is you are multiplying square root of -1 with square root of -1. And again, if you are multiplying square root of -1, we can just combine them together. So negative times negative will end up becoming positive, and you just end up square root of 1, which gives you 4. Go ahead. Yeah, I thought one of you was saying something. Okay, so keep in mind that we define I as square root of -1, but then I square is defined as +1, and this will actually show up later on. So just something to keep in mind. Now, again, when you're typing the answer for this, you can do, again, the plus or minus like I showed you in the previous example. Okay, let's go ahead and clear this out. So we basically have -5 plus or minus 9. And again, I would actually use the I from your menu options here instead of doing it from your keyboard, because again, sometimes it does not recognize the input from your keyboard. So I would say maybe try it both ways and see what works. But normally I just use the I from our my MATLAB menu over here. So again, we'll do a quick check, and you can see that's how your square root property works out. So just to kind of show you how those different examples do. Now, our next method was our completing the square. Now, we actually talked about completing the square. If you saw the video lecture for section 1.3, we actually talk about completing the square when we are trying to find the equation for the circle. So that's the same process that's actually happening over here. We're using the same concept of completing the square, and you'll be seeing completing the square again in the next couple chapters over here. But the idea is, the square root property and factoring do not work on every type of quadratic equation, so they will have restrictions. But completing the square, you can work that with any type of quadratic equation. So you can use it on any type of quadratic equation, and it will definitely work out for us. So let's take a look at how the square root property works over here. So we'll pick another example from homework. These type of questions which are asking you to find the perfect square trinomial are just for the purpose of getting you to practice how completing the square works. So you're not solving your equations over here. You're just doing, the completing the square part. So the way completing the square works is you only need the first two terms of your equation over here. So we actually need the x squared term and the x term. So these are the only two terms we need when we are working with completing the square. So we can actually go ahead and move that 50 to the other side. So you will end up with x squared plus 4x let's see, x squared plus 4x, and then 50 is now on the other side. Now, when we are talking about completing the square, the idea is we take the middle term of our equation, we divide it by 2, or basically take its half, and then whatever answer you get, we then end up squaring that result. So this is the process that we have to follow. Okay, Elijah, no problem. Sorry about that. So yeah, take your coefficient from the middle term, divide by 2, and square it. So of course, for us, the coefficient of our middle term is going to be the number 4. So we are basically taking 4, dividing it by 2, and then squaring that answer, which will end up giving us 4 divided by 2 is 2. 2 squared is going to be 4. So 4 is the number we actually need to create that perfect square trinomial. So this 4, we are now going to add it to both sides of our equation. So that means we will have x squared plus 4x plus 4 on the left-hand side, and then 50 plus 4 on the right-hand side. Because remember when we had talked about that addition property of equality back in section 1, how we were saying whatever you do to the left-hand side, we do that same thing to the right-hand side so that we can maintain the balance of our equation. So that's the same thing we are doing here. So go ahead and add the numbers on the right-hand side. And then the left-hand side, of course, we will need to, factor these guys out. So can you tell me, when we factor x squared plus 4x plus 4, what do we end up getting?
Is +2.
Yeah,
Then,
nice measure. So you've got x squared plus 4x plus 2 plus 4. And the idea is you're basically looking for two numbers that multiply to give you 4 and add up to give you 4, because both our middle term and last term are 4. So that would be 2 times 2. When I multiply 2 times 2, I get 4. When I add 2 times 2 plus 2, I also get 4. So yeah, very nice. This will factor into x plus 2 and x plus 2. So that ends up giving us basically x plus 2 to the second power. And one more thing I wanted to actually point out, this number 2 over here is actually going to be the same one that we calculated right over here when we took our 4 divided by 2. So right before you square the number, whatever that value is, that's actually what your perfect square trinomial is going to factor into. So now coming back to our equation, our left-hand side factors into x plus 2. The whole quantity squared equals 54. So you will notice this equation now over here looks very similar to what we just did with our square root property example. So that's the same thing we are going to do now to get our answer for the equation, is use the square root property. If my pen will let me write, it's been acting a little funny these couple days. All right, so square root property. So remember, this is where we take our square root on both sides of our equation. And then with the square root, we get a positive and a negative sign. So on the left-hand side, the square and the square root cancel each other out. And you should end up with x plus 2 on the left. And then let's see, how can we simplify that square root of 54? What can we do? Because 54 itself is not a perfect square number, right? So what can we bring outside from the 54?
Wouldn't it be 3 times the square root of 6?
3 times the square root of 6. All right, let's take a look at that. So that means you are actually rewriting 54 as 9 times 6, right? And then since 9 is a perfect square, we can do square root of 9, and square root of 9 will end up becoming 3. And 6, since that cannot be broken down anymore, because 6 is only 2 times 3, we don't have a perfect square in there. Yeah, very nice. You will end up getting 3 times square root of 6. And then, of course, now we have to get our x by itself, which means go ahead and move that 2 to the other side. You're just subtracting 2, and this will be your final answer. So negative 2 plus or minus 3 times square root of 6. Now we can't technically really add 2 into 3 times square root of 6 unless you do it as a decimal answer. And they don't want decimal answers over here. They want exact answers. So just leave them as it is. And again, if you wanted to type these as 2 separate answers, just go ahead and separate them from that plus or minus sign. Okay, so that's what you would end up having over here. So let's go ahead and type this in. Okay, so again, we've got -2. I'm using the plus or minus sign. 3 times square root of 6. Let me clear this out. Okay, there we go. And then we'll do a quick check over here. Okay, so that's just an example to show you how completing the square works. And you will see completing the square actually just helps us write the equation in the format that we will then be able to use the square root property to solve them. So completing the square is actually not solving the quadratic equation. Completing the square is helping us rewrite it in the format where we have that, square term on the left-hand side, a number on the right-hand side, and then we can use the square root property to solve it. I actually wanted to show you one more example on completing the square, and it's this one right over here, because what's happening in this example is you will notice we have a 6 on our x squared term. Now, completing the square process only works when the coefficient on your leading term is going to be 1. So you actually cannot have a 6 on that side, because with the 6 being there on x squared, you will not be able to use completing the square just the way it's given to us. So that's actually going to be our first step over here, is to get rid of that 6. The other thing you will notice that constant term 5 is already on the right hand side, so we didn't need to move that term. So you are given 6x squared plus 13x equals 5. So we want to get rid of that 6 on x squared, which means we will go ahead and divide the entire equation by 6. And again, remember, we are not trying to change the value of our equation over here. So if I'm dividing 6x squared by 6, I have to do that for the entire equation. So on that first term, of course, our 6 and 6 will cancel out, giving us that coefficient of 1, which is what we wanted. So now this guy will become x squared. Our middle term will be 13 over 6x. And then, of course, we will have 5 over 6 on this side. So remember, when we were talking about completing the square, we said take the middle term, divide it by 2, and that squared the whole thing. You can actually also rewrite this guy as take your middle term, take its half. So instead of dividing by 2, you can also multiply by 1/2. And then, of course, go ahead and take its square. So that's the same thing we are going to do, since we have that fraction 13 over 6 as our middle coefficient over here. So we're going to take 13 over 6 multiplied by 1/2 and then square that result. So neither 6 nor 2 go into 13, so we're not able to simplify this fraction, so just go ahead and multiply it. 13 times 1 is 13. Of course, 6 times 2 is 12. So you get 13 over 12, and then we square this number. So 13 multiplied into itself is 169. Of course, 12 multiplied into itself is 144. So that means we're taking 169 over 144 and adding that to both sides of our equation. So on the left-hand side, x squared plus 13 over 6x plus 169 over 144. And obviously adding that to the right-hand side also, so 5 over 6 plus 169 over 144. So we need to factor the left-hand side and we need to add the right-hand side. So can you tell me what is 5/6 added with 169 over 144? So you are trying to add two fractions that have different denominators. So you want to try and find that common denominator. So do we know what's the common denominator between 6 and 144?
Is it 24?
24 would be too small, right, for 144?
Would it be 12?
So it's got to be large enough that we can divide both 6 and 144 into that number.
144.
Yeah, so you actually want to see if 6 goes evenly into 144. And I don't know if that's where you got the 24 from, Jacob? Yeah?
Yeah, that's where I got it from.
Okay, yeah. So if you just take 144 and divide it by 6, you will see that 6 goes into 144 24 times. So you actually want to use 144 as your common denominator, which means you would be multiplying that 5 over 6 by 24. And that will end up giving us that common denominator of 144. So you are basically, getting that common denominator 144. We're multiplying this guy by 24. So 5 times 24 will give us what?
It's 120.
Yeah, it's 120. Yeah, very nice. Dalton just sent it on chat also. So yeah, just take 120, add it with 169, and you will of course end up getting your fraction on the right hand side. So that comes out to be 289 over 144. Now, can you tell me what our factored term on the left hand side will be? We have x squared plus 13 over 6x plus 169 over 144. So again, if you think about this, we are looking for two numbers that multiply to give us 169 over 144, but add up to give us 13 over 6. Think about what I told you in the previous example about what those factors should look like.
It will be x plus 13 over 12.
Yeah, very nice, Maka. Because remember I told you it's always going to be this number over here right before you square it. So if we take 13 over 12 and multiply into itself, we know we are going to end up getting 169 over 144. Now, just to verify that when we add those two numbers, it will end up giving us that middle term of 13 over 6. Just add these. So of course, we have a common denominator of 12. So that stays the same. 13 plus 13 will end up giving us 26. And then you can actually reduce our 26 and 12 because both of those numbers will go into 2. So 26 goes into 2 13 times. 12, of course, goes into 2 6 times. And you will see we end up getting that middle term of 13 over 6. So that's exactly what this is going to factor into. X plus 13 over 12 to the second power. So coming back to our equation over here, now we just have to clean this up and come up with our answer for x. So once we get down to this step over here, then remember we are just using the square root property. So that means we will have x plus 13 twelfths square equals 289 over 144. Then we take a square root on both sides, plus or minus. Can you tell me 289 when we take a square root on that? What number do we get?
17.
17, yeah, very nice. So x plus 13 over 12, and then on this side, 17 over 12. Don't forget the plus or minus over here. So can you tell me what our answers for x will be? And because of that plus or minus sign, you should get two different answers. Okay, Dalton, you should be able to reduce those answers. And again, leave your answers as fractions and don't convert them to decimals. Alrighty. So what are the rest of you coming up with? Okay, let's see. Maka, you've got negative 5/12 and 5/2. Dalton gave us 1/3 and negative 5/2. Okay, let's see. Noah, Allison, you guys have negative 5/2 and 1/3. Okay. What else do you guys have? Okay, Chloe, you've got 1/3 and negative 5/2. Okay. All right, so let's take a look at this. Daisy, you've got negative 5/2, positive 1/3. Okay, so Maka, looks like you may want to check your math then, because most everybody seems to be coming up with that 1/3 and negative 5.
Yeah, I got 1/3 as well.
Okay, all right, Jacob. So yeah, because you are doing with, remember, as I said, you're doing it once with the plus sign, once with the minus sign. So basically, if we do this negative 13/12 and negative 17/12, of course, we have that common denominator of 12. So you're just adding the numerators, which will come out to be negative 30/12. And then, of course, you can reduce this because 6 will go into both of these numbers. So 6 goes into 35 times, so that's where the negative 5 is coming from. 6 goes into 12, of course, twice. So that's our negative 5/2, and then negative 13/12, but this time you are adding 17/12, so keeping that common denominator of 12, but now adding negative 13 with positive 17 will of course end up giving us just 4, and 4 goes into itself once, 4 goes into 12, 3 times. So that's where we are coming up with these answers of negative 5/2 and positive 1/3. Alrighty, so let's go ahead and type our answers in over here. So we'll do negative 5/2 and positive 1/3. And let's see, what does my math lab say? Okay, there you go. So positive 1/3 and negative 5/2. So just a different way of, how our completing the square process will work when your leading coefficient is not 1. So like you have that 6 on the x square, you need to first get rid of that before you can use completing the square. So just to show you that different example. And then, you've got these steps over here walking us through the process of completing the square. So when you're working on your homework, you want to make sure you're doing it correctly. You can always come back and take a look at these steps over here. Now, quadratic formula also works on every single type of a quadratic equation. So if any of the other methods are not working out for you, you can definitely always use the quadratic formula to try and come up with the answer for our quadratic equation. Now, based on that part which is inside our radical over here, the b squared minus 4ac, that actually tells you what type of answers our equation is going to have. So, just like when we were doing our square root property over here, and they told us if you had a positive k, you had 2 real solutions, negative k, 2 imaginary. If it's 0, then you have only 1 solution. In that same way, that value inside of the square root can actually tell us what kind of a solution our equation will have. So that b squared minus 4ac part is what we call as the discriminant. And based on the value of the discriminant, we will know what type of solutions our equation will have. So again, if that b squared minus 4ac, or if our discriminant is a positive number, our equation will end up having 2 real solutions. If our discriminant value is going to be negative, then we will actually end up having 2 imaginary solutions, or basically our answers are not going to be real numbers. So they're not real solutions, they are going to be 2 imaginary solutions. And if our discriminant comes out to be 0, then we actually only have 1 solution, and that 1 solution is going to be in the form of negative b over 2a. So just think about that. We are saying in here that if our square root part comes out to be 0, then, of course, square root of 0 is going to be 0, which means this part will disappear. And then if we don't have a number over here, it's just a 0. That means we don't have to worry about the plus or minus sign either. So as you will see, we do in fact end up getting just negative b over 2a as our solution over here. So that happens when our discriminant is going to be 0. Now you will actually have some examples in your homework where they will ask you to basically just figure out what the discriminant value is, and based on that to try and see how many real solutions we will have. So they're just interested in real solutions, not the imaginary ones. So if our discriminant value is going to be positive, we get 2 real solutions. If our discriminant value is going to be 0, we get 1 real solution, and we just saw that here with negative b over 2a. And if the discriminant value is going to be a negative number, then that's when we know we are not going to have any real solutions. There will be 0 real solutions, but that also means, yeah, we don't have real solutions, but remember, we do have 2 imaginary solutions. They're just not real numbers. That's basically what that means. So you will still have imaginary solutions for that one. So let's take a look at example of how we can use our quadratic formula over here. So you can see there's going to be a couple different types of examples for your quadratic formula, but this is the one that I wanted to work on. So let's take a look at this guy here. We are given 2x squared minus 2x equals negative 5. Now, the one thing you always want to be careful about when you are using the quadratic formula, always rewrite your quadratic equation in the standard form, which means get all the 3 terms on one side and get 0 on the other side. So that's one thing you always have to do when you're using the quadratic formula. So of course that means we need to take that negative 5 and move it to the left-hand side. So we'll go ahead and add that 5 to both sides of our equation, and we will now have 2x squared, there we go, 2x squared minus 2x plus 5. And then, of course, we will have equal to 0 on the other side. So our quadratic formula is going to be x equals negative b plus or minus square root of b squared minus 4ac, and then the whole thing divided by 2a. But you know, the first thing we're actually going to do is just look at our discriminant over here. So let's look at b squared minus 4ac. So of course we know the leading coefficient is going to be our a term, the middle coefficient is the b term, and the constant term is our c term. So that's where we're going to get our ABC values from. So let's see, b is -2. And keep in mind the sign always goes with the number. So if you had a negative for the a value, you know, if it, for some reason it was -2x squared, you want to include the negative sign with that. Same thing with b and c. If there's a negative sign right before the number, you want to make sure you're including the negative sign with the number. So like here, our b has a negative in front of it, which means b squared, we're going to write it as -2 squared minus 4 times a in our case is +2, and c is also +5. So we'll go ahead and do the math over here. So can you tell me what this value comes out to be? So when you simplify that -2 squared minus 4 times 2 times 5, what do you get?
Would you need to FOIL the 4 to the 2 and the 5?
Yeah, you're multiplying all three of those numbers together.
Would it be -36?
-36, okay. And let's see, something came on chat. Dalton also got -36. Yeah, because you know, when we do -2 to the second power, that becomes +4. And then, like I was just telling Jacob here, you're multiplying the last three numbers, 4 times 2 times 5. So of course that ends up becoming -40, or 4 minus 40. And since you're doing 4 minus 40, then yes, we do end up with -36. So remember, they told us if you have a negative answer for the discriminant, we end up getting two imaginary solutions. So this was that second case we talked about. So since we are coming up with -36, of course, that means we are going to have two imaginary solutions for this equation. Okay, there we go. So we're just going to go ahead and write that down so we know what to expect. Okay, so now let's get back to our quadratic equation over here. So you've got -b. So that negative is coming from the formula itself. And then remember, our b is also -2. So we should actually have two negative signs over here, plus or minus. We have our discriminant, b squared minus 4ac. So that was -2 to the second power minus 4 times 2 times 5. And then denominator is 2 times a, and of course a is also 2. So just cleaning this up, of course you will see on that first part where we have two negative signs, these two negatives will end up becoming positive. So we end up with +2 plus or minus square root of -36, since we already solved that part, divided by 2 times 2 will end up becoming 4. So of course we want to try and simplify that square root of -36, and what will that end up becoming here? When you simplify square root of -36?
Plus or minus 6i.
Very nice, Maka. Yeah, because again, you know, you are separating that negative sign from the number. So square root of -1 becomes I. Square root of 36, of course, will be 6. So you end up getting 6i, and then bringing it back we will have 2 plus or minus 6i divided by 4. Now, one other thing that I actually want to point out that I guess I didn't really talk about earlier, when we have our imaginary numbers, actually when they are in this form where you have both the real and the imaginary part with it, we actually call them as complex numbers. And complex numbers have the form of a plus bi, where that first part is what we call as the real part because that will be the real number. And then the second part that has the I on it, of course, that's the one we call as the imaginary part. So what's going to happen here in our 2 plus or minus 6i divided by 4, we do actually want to separate them into the real part and the imaginary part. So I'm going to take that denominator and split it as 2 over 4 and then plus or minus 6 over 4 and then put the I after that. So we can kind of keep this format of a plus bi, and then of course all we have to do is reduce those fractions. So what does our final answer end up looking like? So just separating the real and the imaginary part by splitting that denominator. So when you reduce those fractions, what do you get? Okay, let me see, send something on chat over here. Okay, so Maka, you've got 1/2.
Yeah, was a typing error. Yeah, one half plus or minus 3 over 2i.
Very nice. Yeah, so all we have to do is just reduce those fractions. So 1/4 will reduce down to 1/2 plus or minus. Again, 6 and 4 will have a 2 in common, so reduce by 2. We get 3/2 and then I. So that's going to be our answer for this equation. And again, if you wanted to put this in two different answers, you would have 1/2 minus 3/2 I. And then of course 1/2 plus 3/2 I. Okay, so let's go ahead and type our answer in over here. Smaller, there we go. 1/2 plus or minus 3/2, and then we need I, which is right over here. Right, and then let's check that answer. Alrighty, and we're good to go. So just to show you again how the quadratic formula would work out with this type of an equation. Now this is where I was talking about where they will just ask you to find the value of the discriminant and write how many real solutions you have. So you're not solving the equation here, you're just working with the discriminant. So you do have a couple examples on that. Now this one here is saying, choose a method that you want to do. So you can use factoring if you think factoring will work. Probably not square root property directly. So you would have to use completing the square if you wanted to use the square root property. Or of course, you always have the option of the quadratic formula. This next example here is the same thing. They're asking you to choose a method that you want to use over here. Now, before you are able to start solving this, what do you think should be the first thing we need to do in this example here? You're given x equals 5 plus 7 over x. So just what do you think would be your first step here to try and solve this?
Would we need to, oh, sorry, go ahead.
Multiply each term with x.
Multiply each term with x? Yeah, because right now you will see, guys, that we don't really have that x square term, right? It's 7 divided by x. So yeah, exactly. That's the first step you want to do, is take your entire equation and multiply it by x. So that means your first term, the second term, and the third term, each one of them has to be multiplied by x. So that will end up giving us, let's see, x times x will give us x squared. 5 times x on the other side will of course end up giving us 5x. And then what's going to happen in that last term here? Jacob, you want to help us out, since I know you were trying to say something last time?
Would it be x squared? Like
No,
7x.
Because you've got 7 over x, right? And we're multiplying it with x. So what do you think happens with our x terms?
Does it just disappear? Or?
Yeah, exactly. So that's exactly what's going to happen here in the last term is, you know, those two x's, when you multiply, cancel out, and just giving you that constant number of 7. Come on, pen. There we go. So yeah, just multiply the entire equation by x, so that you can, you know, get rid of that denominator. You can have your nice quadratic equation. And then again, I would suggest try factoring. If factoring doesn't work, then maybe try completing the square or your quadratic formula in this case. But you will need to do that extra step of cleaning up this equation. So again, kind of use that example when you try to do this in your homework. Okay, let's make this guy smaller. And then this example should look a little bit familiar to you, because we had done something similar to this example in, I think it was section 1.1. So use the same techniques, which is basically use cross multiplication. So multiply your x minus 12 with x plus 1, you know, FOIL that. On the other side, you will multiply x plus 23 with 3 minus x, FOIL that. And then, you know, of course, try and get your terms together and solve your equation accordingly. So I want to try this example on, I want you guys to try this example on your own, and let me see what you come up with. So if you get stuck on it, you need extra help with this assignment, you know, when you work on homework, just let me know and we can work on it together. But for now, I'm not going to go over it with you guys. I want you to try it on your own. So just different ways of solving a quadratic equation. On your video lecture, you should also see these couple of application problems. So just so you're aware of, you know, how we can use these quadratic equations. Now our next section over here is continuing our discussion of solving equations. So we talked about equations with just one variable in section 1.1, and in section 1.2 where we saw you know, applications. In section 1.3 we talked about equations with two variables. So equation of a line, equation of a circle. Of course, in 1.5 we just talked about quadratic equations. So now we're just getting into some other types of equations. So this one here, we're starting out with higher degree polynomial equations, and we want to try and use factoring to solve some of these examples over here. So if you again look at your homework examples over here, number 1 over here is very similar to number 1 from our handout over here. So I just follow the instructions that I have for number 1. But this next example is the one I wanted to look at, where you have a to the 4th minus 256. So again, remember we have to use the factoring method to try and solve this. So let's bring this down here. A to the 4th minus 256 equals 0. Can you tell me what is the 4th root of 256? Since you do have that a to the 4th, we know we are looking at the 4th power. or basically what number multiplied into itself 4 times will give us 256. Let's see, we've got a couple answers coming through. Okay, Noah and Allison. Dalton, you guys have 4. Yeah, very nice. If you just take 4 to the 4th power, you are coming up with 256. So very nice. So this will be the number 4 here. So I am actually going to rewrite this as a to the 4th minus 4 to the 4th equals 0. Now, can you tell me what factoring method we can use to try and solve this equation? Anything that maybe you have used or coming to your mind? Go ahead, Maka.
Difference of squares.
Yeah, exactly. So just to refresh your memory over here, difference of squares is, basically where you have 2 square terms and you're taking obviously a minus sign on them. So this is what difference of squares would look like. And you can actually think about it just as a square minus b square. You don't really have to think of it as an equation, but it factors into a plus b and a minus b. Now, of course, in our case, we don't really have square terms. We have the 4th power, but we can still use the same concept. All we have to do is rewrite our a to the 4th and 4 to the 4th power in terms of squares. So I can actually write this as a to the 2nd power and then raise that again to the 2nd power minus 4 to the 2nd power, and then again raise that to a 2nd power also, because remember, when we do a to the 2nd power and then raise it again to the 2nd power, basically 2 times 2 will end up giving us 4. And then, with these guys, this a square is now acting like our a term over here, and the 4 square is acting like our b term over here. So when you break this down into a plus b and a minus b, this will actually be a square, this will be 4 square, and again, this will be a square, this will be 4 square. So you're still using that same format, but obviously we're having to modify it from a 4th degree to a 2nd degree. So by difference of squares, this will become a square plus 4 square, or you can write it as 16, a square minus 4 square equals 0. So use this idea of difference of squares to help us out in factoring this. And now just to clean this up, let's write this as a square plus 16, a square minus 16 equals 0. And now, of course, using the 0 factor property, we take each factor and set it equal to 0. So what do you think our answers will come out to be here? I'll give you guys a couple minutes to come up with the answers for these. The total, we should be coming up with 4 answers. So just have your answer ready. Don't send it through the chat till I ask you to. I want to give everybody a chance to work on this. So just have your answers ready, and when I ask you to, you can send it. Don't send it just yet. Okay, go ahead and send your answers in. Okay, let's see, I've got 4i and 4. I've got 4i and 4, positive and negative 4, positive and negative 4i. Okay, I've got positive, negative 4, positive, negative 4i. And then some of you've got positive, negative 4. Alrighty, so yeah, you should actually have 4 answers. Now let's do this one on the right hand side. So you've got a square equals 16. So again, if we use our square root property over here, take a square root on both sides, so it will give you one positive, one negative answer. Square and square root cancel out, just leaving us with a. And then when you take square root of 16, you of course end up getting 4. So those are going to be 2 of our answers, negative 4 and positive 4. Now on the other side, with a square equals minus 16, we'll still use our square root property over here. But when we take our square root, again, we have a equals, but now we are looking at square root of negative 16, right? So that's where your imaginary solutions are coming into play. So again, separate that negative sign from the number itself. So square root of negative 1 is I. Square root of 16, of course, is 4. So you end up getting positive or negative 4i. So you will actually have a combination of real numbers and imaginary numbers as your solution set in this case. Alrighty, good job, guys. So if you were having a little bit of doubt, because I know some of you only sent the real number answers in, just don't get confused because you had imaginary and real number parts in there. It's okay to have, you know, both of them as part of your answers in here. So let's go ahead and type this in. I'm actually going to go ahead and clear this out. So we will have positive and negative 4. I'm just typing, you know, those 2 answers, and then I'll do again positive and negative 4i. Let me get my I over here. There you go. And enter, and again, you will see that works out. Okay, so this was, you know, how to use factoring in a higher degree polynomial example. Now, we also have other types of equations that we are looking at here. So we've got equations that involve square roots, so that would end up looking like, you know, a couple of these examples over here. You can also actually have equations that have rational exponents. So you will see we've got a fraction in our exponent over here. And then these ones are actually really interesting type of equations because they're talking about equations that could be in a similar type as a quadratic equation. So you can use your techniques from quadratic equations to actually solve equations of this type. And then we are also actually bringing back the idea of absolute value equations and how you would work them, you know, maybe with a higher degree polynomial. So let's start out by talking about these equations with square roots in them. So the idea here is you want to try and isolate your square root, your radical, get it to one side of your equation and move everything else to the other side. So isolate the radical. If you have more than one radical, then you want to bring it to opposite sides of your equation. So that would be, you know, something like number 4. You want one radical on the left-hand side and you want to move the other radical to the right-hand side. Then we go ahead and square both sides of our equation, you know, try and simplify what we can. And the idea is if you still have any more radicals left after we do step 2, then you actually want to repeat steps 1 and 2. So basically you start by isolating your radicals again, and you would end up squaring both sides of your equation again. Now, the one thing we have to be really careful about when we do these type of examples, we want to make sure we are checking all of our solutions, because anytime you do a square, you actually end up creating extraneous solutions, which means you will have solutions which will not satisfy the original equations. You're basically getting extra answers, and that's what we mean by extraneous root. So you always want to check all the solutions that you come up with into the original equation. If you get a true statement, that means that number or that solution is satisfying the original equation. But if you end up getting a false statement, then of course you want to discard that answer. And you know, sometimes you may end up with equations that have only one solution that you came up with. And if that one solution is not satisfying the original equation, you need to discard that, and you will basically end up saying your equation has no solution. So let's take a look at this example over here. So we are given x plus 7 inside the square root on the left-hand side and x minus 5 on the right-hand side. So you will see my radical is already on one side and all the other terms are on the other side. So we can go ahead and directly start by squaring both sides of our equation. Okay, so square the left-hand side, square the right-hand side. Now, of course, on the left-hand side, that square root and the square will cancel out. On the right-hand side, since we are doing x minus 5, the whole quantity squared, we actually want to use FOIL on the right-hand side. So we'll multiply the right-hand side. So that should end up giving us, let's see, on the left, the square root and square cancel out. So we're left with x plus 7. And then what happens when we FOIL our x minus 5 quantity squared? I think this will give us.
Will it be x squared plus 25?
No, because remember, this is where we also multiply the inside terms. So you should get 3 terms in your answer.
Oh, okay.
Okay.
Can it be x squared minus 10x plus 25?
Yeah, so you should have 3 terms. Very nice. Because remember, you're multiplying the first, the outer, the inner, and the last term. So that will end up giving us x squared minus 5x minus 5x, and then the last 2 terms is negative 5 and negative 5, which gives you positive 25. And then when you add up those middle terms, you will end up getting x squared minus 10x plus 25. So yeah, just be careful when you're doing your FOIL. So let's bring that down to our right-hand side. So x squared minus 10x plus 25. Now, you want to try and get the like terms together. So that means we'll go ahead and subtract our 7 and bring it here with the 25. And then let's move that x also. So subtract that x and we'll bring it to the middle term with minus 10x. So get 0 on the left. And then let's see, we end up with x squared minus 10x minus 1x will end up becoming minus 11x. And 25 minus 7 will end up giving us what? 18. Okay, so now you can see we have a quadratic equation, x squared minus 11x plus 18. So again, you have the option of using factoring, completing the square, quadratic formula. Honestly, I think factoring is going to be the more straightforward method. So we're looking for 2 numbers that multiply to give us 18, but add up to give us negative 11. So multiply 2 numbers to get 18 and add up to a negative 11.
Would it be 9 and negative 2?
So would 9 be positive?
No, it'd be negative.
Yeah, very nice, because you want both numbers to be negative, negative 9 and negative 2. So negative times negative will become positive, so we'll get 18 when we multiply them. But then when we add negative 9 and negative 2, that will add up to negative 11. Alrighty, very nice. So let's factor this guy into x minus 9 and x minus 2. We'll take each one of the factors, set it equal to 0. And then of course, as you can see, we will get x equals 9 or x equals 2. But remember, this is the equation where we need to check our solutions to make sure we don't have any of those extraneous roots. So checking is a very crucial part of this problem over here. So our original equation was square root of x plus 7 on the left and then x minus 5 on the right. So let's start by checking with our x equals 9. So what would that be? 9 plus 7 over here and 9 minus 5 over here. And you want to repeat that checking process with x equals 2. So that would be 2 plus 7 on the left-hand side. And that's, of course, inside the square root. And then we would have 2 minus 5 on the right-hand side. So go ahead, do those two checkings. And can you tell me out of the 2 and the 9, which one works? Neither works, or do both of them work?
9 works.
9 works, okay. Yeah, because when you add 9 and 7, of course, you end up getting 16. So that's going to be square root of 16. And then on the right-hand side, 9 minus 5 will, of course, end up giving us 4. Square root of 16 is 4. So you can see we end up getting 4 equals 4, which is a true statement. So x equals 9 is going to work. Actually, right here, you should see why this is not going to work, because when we do 2 minus 5, we get negative 3. And, you know, of course, we're not going to be getting a negative answer from the left-hand side, because when we add 2 and 7, we get 9. Square root of 9 is going to be 3. And, of course, we are ending up with a false statement on this side, which is, again, telling us x equals 2 is not going to be a solution. So this guy is, you know, what we would call as the extraneous root. Well, not here, but this one here is our extraneous root. So when you're typing your answer in, of course, the only answer goes in is going to be number 9. So just be careful with these type of examples, because you do have to make that consideration of the extraneous root when we apply these squares on both sides of our equation. Okay, so our next type of equation was, oh, and I did want to talk about this, hold on. So when you have, oh, that's right. In this example, I would recommend you guys to again multiply both sides of your equation by 7, so you can get rid of that denominator. So get rid of that denominator before you start solving this example. With the next example over here, you definitely want to move one of those radicals to the right-hand side and try solving it accordingly. Again, from your video lectures, if you look at how we did number 4, you should be able to follow those same instructions to try and do number 5 from your homework over here. But I wanted to talk about this example over here where you have rational exponents. So what happens with these type of examples where you are given rational exponents, you know, we still have to get our x by itself. That means we have to find a way to get rid of that exponent, which is m over n. So you will see they're telling us to raise each side of our equation to the reciprocal power of n over m. So originally it's m over n, and you know, of course, you just flip that fraction and make it n over m. And so the idea is, if your m is going to be an even number and this k value here is going to be positive, you will actually come up with 2 solutions. If your m is an even number but k happens to be a negative, then they're telling you you get no real solution, but that also means you will have 2 imaginary solutions. So just because it's not a real number doesn't mean you don't have a solution. They're just going to be part of the imaginary numbers. Now, if m is an odd number, then it really doesn't matter if your k is positive or negative. You will only have 1 real solution if m is an odd number. Now, they're telling us here in step 2, remember that there are 2 real even roots for any positive real number, and there are exactly one real odd root for any real number. So just kind of remembering what type of solutions you can come up with. So let's take a look at how we go about solving something like this. So the very first step is you raise both sides of your equation to the reciprocal power of the exponent over here. You know what, let's write it down over here. So we've got x to the 2/5 power equals 2. So raise it to the reciprocal power, which means these guys will become 5/2 and 5/2. Now the idea is when I take 2/5 and multiply it with its reciprocal 5/2, you can of course see our numbers will cancel each other out and we end up getting 1. So that's actually how we try and get our variable by itself, by raising it to the reciprocal, so they cancel each other out and we get our variable just by itself. Now on the right hand side, you've got 2 raised to the power of 5/2. Now if you go back to your handout over here, they are telling us when we have an m as being even number and our k being positive, we are going to have one positive and one negative root, and this is coming from step 3. That's the same thing we actually have over here. You will see our denominator is 2, which is an even number, and our base here, this 2 is also a positive number, so you will actually get one positive and one negative root. Now this is happening because if you look at the general form of a raised to the power of m over n, this actually means that n is telling you what kind of root we have. So that's the index of your radical, and we have a raised to the power of m. So technically when you have 2 raised to the power of 5/2, that bottom 2 on our fraction is actually telling us that we're looking at a square root, and we have 2 to the 5th power on the inside. So since this is a square root, remember with square roots, we always get one positive and one negative root. So that's kind of what they're talking about, is when this bottom number is an even number, you are going to end up getting 2 solutions, for your x value over here. So that's why we're going to have a positive and a negative answer over here. Now there's a couple different ways you can come up with the answer. So if you just look at square root of 2/5, you can actually break this down into 2 to the 4th power times 2. 2 to the 4th power you can simplify by basically converting it into a rational exponent again and leaving our single 2 inside the radical. So as you will see, this guy cleans up into 2 to the 2nd power times square root of 2, or basically 4 square root of 2. That's one way of doing it. If you're not comfortable doing it that way, then just start out by finding what is 2 to the 5th power. So just, figure out what 2 to the 5th power is, which will end up giving us 32. So we have square root of 32. Break that down just like you would be simplifying a radical. So you can rewrite this guy as 16 times 2. Square root of 16 will be 4. And that 2 again ends up staying inside the radical. So whichever way you want to simplify this, it doesn't matter as long as you are simplifying your radical over here. Again, remember we have one positive, one negative root. So when you clean this up, you end up getting plus or minus 4 square root of 2. But if you don't remember that the bottom number was an even number and we have, a square root, and you forget to do the positive and negatives, obviously my math lab will count that as being wrong. So just be careful about that. Now, if your denominator was like a 3, 5/3, you would have had only one answer in this case. So this one does not let us do positive and negative. So you will have to type these in as two separate answers. So we'll have -4 square root of 2. And then I'm using my right arrow to actually come outside of the radical. And then we'll do 4 times square root of 2. So let's check this, and there you go. Just a different type of an example, you know, when we're working with rational exponents, or basically where you have exponents in your fractions. Now, remember I was talking about these quadratic type of equations. So what that actually means is we have to use this U substitution to try and, you know, make it look like a quadratic equation, because if we can make it look like a quadratic equation, then we can use those techniques from section 1.5 to try and solve this. So the way U substitution works is actually you look at your variable term on the middle term. You don't have to worry about the numbers, you're just looking at the variable portion of it. So that x squared is what we are going to substitute for our U. So we will say, okay, let U equal x squared. Now, if I go ahead and take a square on both sides of this substitution that we just did, you will see when we do x to the second power raised to that second power, 2 times 2 will end up giving us 4. That actually comes out to be that first term of your equation. So then what happens is, this is where the substitution will happen. Instead of x to the 4th, we will now write that as u to the second power. Minus 9 will stay as it is. We're writing x squared as u plus 20 equal 0. And now you will see, yes, this does look like a quadratic equation. So you can actually use factoring to solve this, or you can use quadratic formula. Once you find your answer for u, whatever is that that answer comes out to be, go back and substitute your u for x squared. So come back and say, okay, x squared is now going to equal this answer. And then, you know, you can go ahead and solve for x. So that's basically the idea behind these types of equations. When you're looking at number 7, again, just the variable part is what we use for our u substitution. So our u is going to be just that x squared plus x part. And again, if I go ahead and do a square on both sides of this, you will notice that comes out to be our first term over here. So same thing, replace that with u squared minus 8. The middle term would be u plus 12. And again, now you can use factoring or a quadratic formula to solve this, get your answer for u. But now, of course, we will be setting our answer equal to x squared plus x. And then, you know, of course, we're going to find our x by repeating the process over here. Even for something like number 8, use that middle term to get your u value. So that would be x to the 1/3. Again, we will go ahead and raise both sides of our equation to the second power. If it helps, you can think of this as being 2 to the 2 over 1. So this will end up becoming x raised to the power of 2/3, which is again our leading term. So you end up with u squared minus u minus 6 equals 0. Again, guys, factoring will work out just as well over here, but you can also use quadratic formula, and then you get x to the 1/3 equal to whatever answer you get. Now, for examples like number 8, you know, we would obviously need to come back to this technique that we just talked about to try and simplify an example like number 8. But this is how these equations of the quadratic type end up working. So if you look at your example here in homework, you know, again, something like this is very similar to what I just showed you. So start by rewriting this guy as your u value. So that means u would become x squared minus 6x. If we squared both sides of this, obviously that ends up becoming our first term. So when we do our u substitution, that first term will become u squared minus 50u minus 275 equals 0. Again, I would try factoring over here or quadratic formula. Figure out what answer you can get for u over here, and then whatever this answer is going to be, set it equal to our u, which is x squared minus 6x, you know, and then basically solve for x at that point. So try this. You have your video lectures to help you out with these type of examples. So I want to try and see what you guys are able to come up with. And then, as I was mentioning earlier, anything you get stuck with, you know, come to me for help and I will help you walk through those examples. You've got absolute value examples here on the last couple of them. Use the same techniques you saw in those first sections and use those techniques to help you simplify these absolute value equations, because the process is the same. We're just changing the type of equations that you have. So you should be able to follow your video lecture examples, examples that you have seen in the previous sections, and anything you get stuck on, I am going to be here for you. Now, obviously, we don't have enough time to, you know, start section 1.7, and you actually do have an application here you can look through, because 1.7 is actually now getting into linear and absolute value inequality. So I would like to actually take a class period and talk about that. So let us see. I think officially we have next Tuesday as our exam day, right, for chapter 1. So I'm going to move it to Thursday, which will be the 10th. So that will give you guys basically a week from today for our chapter 1 exam. So instead of doing chapter one exam on Tuesday, we're going to move it to Thursday. So I'll go ahead and make the date changes in my MATLAB for you. But just keep in mind, we're not taking the test on Tuesday. We're going to do it on Thursday. So before you know, we wrap up for today, I wanted to see the different examples that we have gone over. If you needed, if you had any questions on anything, or do you have any questions about the exam or anything like that? Nothing coming up to mind right now?
Will section 1.7 be due on Thursday instead of Tuesday then, like all the other
Yeah.
homework?
Yeah, so I will move all the homework deadlines, the quiz, and the exam to the 10th. So yeah, even your homework, I know most of you are actually done with the first part of your homework, but I will change all the deadlines to September 10th at 9:40, I think is when your class ends. So I'll keep it that same time, but just move it from the 8th to the 10th. Okay, what else?
And then what are we allowed during the test? Are we allowed to have our notes or a calculator?
Yeah, so you can have your notes, and you know, we're not putting any restrictions on calculators, but obviously you don't want to do anything too fancy. I would say scientific calculator or your basic graphing calculator. You do want to submit your own work, and you will actually be logging into class on the day of the exam. So even though we are not, you know, going over examples or lecturing, you will still need to log in, because I will be giving you the password for the exam on that morning. So you're still coming in on Zoom.
So we're staying on Zoom the whole time we're taking the exam as well then? Or
Yeah.
Okay.
You can just keep your, you know, like you guys normally have your mics turned off and anything. But if you get stuck on something, you're not understanding a question, or mainly I'm actually concerned about if you have technical problems, and if you're on Zoom with me, I will be right there to help you guys out. Okay, what else? Okay, so just, I know we don't meet on Monday, so it really doesn't affect us, but just keep in mind Monday is Labor Day. So if you do have any classes on Monday, they will not be happening. I had to keep reminding myself yesterday, because I kept telling my classes I'll be seeing them on Monday, and they were like, no, Ms. Daruka, we're not seeing you on Monday. So have a wonderful long weekend, guys. Be careful, and I will see you on Tuesday next week. Take care, guys. Bye-bye.
Bye.
Bye. Take care. Okay, and Teddy, let me look at your screen, okay? Alrighty, so I will actually need to make you a co-host, and then you should be able to share your screen. Okay, so you should be able to share your screen now.
Oh, which screen is showing?
So you are going to show me your D2L.
Yeah, I'm trying to make sure it's showing the right screen. Here we go, screen 2. So can you see my D2L now?
I can.
Oh, here are the 2 math classes. There's this fall semester one, which is the MA2
And
121.
is that the one that's showing up as the blank one, the R11?
Yeah, once I go in here and go to content, it's completely empty. But if I go to the other one, it has the stuff, but when I click on content,
It's all
go
there.
to my math lab. Everything's here, but then it says this link is only for those students who are enrolled in Monday, Wednesday section.
Yeah, so you are in the Tuesday, Thursday section, right? So this is
Yeah.
for you because
Yeah.
you are this bottom class. So what happens when you click on any one of these links?
So all the links work. That's the thing. Like all of it works just fine. It just acts weird just with this thing. It's strange that
Yeah, so
it
the
doesn't,
reason I put this little note over here was because my Monday, Wednesday afternoon class, which is at 2:15, was actually coming into this class, and this is not for them. This is only for you guys and the Monday, Wednesday morning class. Because you know what happened, Teddy, was you guys, the sections for your classes were created earlier. So I was able to, because you know, you didn't have to pay for my math lab, right? Because they already charged you that when they charged you for the class. So you guys had already prepaid for this, but my Monday, Wednesday class was literally added like the week before we started classes. So they had to pay for my math lab separately. And so that's why they are not allowed to use this link. So it's that little confusion that happened, which is why I had to put this. So you are actually in the Tuesday, Thursday morning class, right? So you are good to go.
I am in the Tuesday, Thursday one. I was just confused because the other one used to show stuff and this class wasn't here before. Then this class appeared and I thought that was like a thing warning me. I just didn't want it to be like, oh, I'm just taking this class and not getting credit for it kind of thing.
No, so this was just because of you guys paid for the My Math Lab with the class and the others did not. So for them, you will notice there's that Monday, Wednesday 2:15 link right underneath this My Math Lab. And that's the link for those students. So you are okay with this.
Okay.
Yeah, and then if you go back to your main D2L page, yeah, so that R11 class you are seeing, that's actually specifically your section. But because I have combined all of my courses together, because of that reason, in the R11 course shell, you're not seeing anything. You're seeing everything in that RC1 course shell.
Okay.
Yeah, so you don't even need to honestly worry about that R11 because you really, as you saw, there was nothing in there. So you can just go directly to the RC1 course shell and you should be okay. And all of your homework and everything, I am able to see that from my end. So everything that you're doing through that My Math Lab link is definitely showing up.
Okay, good. I was just a little weirded out by that thing. I wasn't sure.
Yeah, no, I'm glad you mentioned that because honestly, that R11 shell should have disappeared when I combined all these shells together. But for some reason, it looks like it's still showing up for you. So does that help?
Yes, that helps a lot. Thank you.
Okay, yeah, no problem. Well, you take care.
Okay, I will.
All right, have a good weekend. Bye-bye.
Bye.